Okay, so to start this new little lesson that we're going to do, I want you to do two things. I want you to find the L, the length on that triangle right there, using ideas from hopefully geometry or something like that. And then I want you to graph y equals 2x minus 3. So you should pause the video, do those two things. Might take you a couple minutes. With number 2, give me a couple points and you're good. So go ahead, do that. All right, I'm going to start up again. So with that first one, should have used Pythagorean theorem. I know that a squared plus b squared is c squared, so I've got 7 squared plus 3 squared equals L squared. If I shuffle things around a little bit, that gives me L squared equals, I think, 58. That's 9 and 49 added together. Then I square root. I get L is equal to root 58, which is approximately 7.616. So I'd take that, or I'd take the root 58. Next one. I want you to graph y equals 2x minus 3. So I'm going to go up to, down to negative 3. Maybe undo. Down to negative 3. And then go up 2 over 1 for that slope. And then up 2 over 1 for that slope. And then I'm just going to connect those guys in a line like that. If I was on a gridded paper, I would want it to be more accurate, but that's good enough for now. So, a couple things I want you to think about. One, Pythagorean theorem relates the legs of a triangle to the hypotenuse. This squared plus this squared is always going to be this squared. Second thing I want you to think about, this is the form y equals mx plus b. And I know that y equals mx plus b based on all the stuff that I've done in Algebra 1 and some in Algebra 2. It's always going to give me a straight line. And I can use what I know about y equals mx plus b with slope, y-intercept, and stuff like that to construct that line. Line Pythag. So what we're going to do now is we're actually going to find the kind of equivalent of y equals mx plus b, but for this circle right here. So what I'm going to start by doing is drawing my xy axis in here. I'm going to make it so that the center of that circle is at the origin, is at 0, 0. And now I'm going to draw some triangles. So actually, before I draw triangles, I'm going to draw just a dot right there. Now that point, x comma y, is on the circle, just like any of these points here are on that line. And there, x comma y points too that would fit this. For example, if this point here is 1 comma negative 1. So if I plug in this for the x value, and then I'm going to wind up getting this for the y value. So 2 times 1, the x value, minus 3 gives me negative 1, the y value. So come over here. I'm going to draw a triangle that goes like this. Now, let's say that this circle has a radius of 5. That makes that 5 comma 0. This 0 comma 5. This over here, negative 5 comma 0. And this down here is 0 comma negative 5. Kind of the same pattern as the unit circle when we talked about trig. So, what I want you to notice, that blue triangle that I drew, I've got this length is the radius, it's 5, and then this is my x value for that particular spot right here, who knows what it is, and this is the y value, that length on that triangle. So, let's come over here. Let's pick a point there. I'm going to pick any point anywhere on this triangle, or on this circle. So now watch, I'm going to go down like this. That thing, what's the length of that? Well, it's a circle of radius 5, so it's 5. Now what I'm going to do is drop a line down, bring a line over. Oops, bring a line over like that. Notice this red length is an x value, and this red length here is a y value, and I should mark this as a right triangle. I should mark this as a right triangle. So what I want you to see is that x, that y, part of the circle, and then that 5 is going to be there, right? So same thing here, x value for that point in the circle, y value for that point in the circle. Maybe it's 3, maybe this is 4, and maybe this is 3. Maybe this is 2, and this is some weird square root or something like that. But these are x and y values on those circles. So I filled in a couple more triangles. And I want you to see that here I've got x and y. Oh, I didn't label the colors. So this is 5, and then there would be a purple 5. That, oops, undo. There would be a purple 5 right about there. So what I want you to notice about all these triangles is that all of these triangles have x values and y values that match up on the circle. And they all also have that length right here of 5. So they additionally all have a right angle here. I labeled it on the upper two, but I didn't label it on the lower two. So remember, I'm looking for a y equals mx plus b, but for a circle. I know that y equals mx plus b is always going to give me a straight line. So what I can do here is say that, well, I could take this x value, this blue x value, and this blue y value, and I could write x squared plus y squared, and that would give me 5 squared. I could go over to this x value, whatever it is, this y value, and I would get x squared plus y squared equals 5 squared. I could go to the green. Well, this x value, that y value, that's going to give me 5 squared by Pythag. So I get x squared plus y squared equals 5 squared. I could do the same thing for the purple. What I want you to realize is that it doesn't matter what point I select on this circle, but that x squared for that point, whatever that point is, plus the y squared, whatever that thing is always going to be 5 squared, because I can always draw a triangle like this for that point, and it's always going to fit that. So we've kind of backed our way into the equation of a circle. For this thing, it would be x squared plus y squared equals 25. You should be able to infer where the 25 comes from, where the 5 squared comes from. What if I were to change the circle to a circle, say it was a radius of 3. Say I had a circle centered at the origin whose radius is 3. Well, I could do the same thing with little triangles. What I wind up getting is that x squared plus y squared equals, you got it, 3 squared, which is 9. So, boom, I have y equals mx plus b for a circle. So for any circle, instead of writing y equals mx plus b and thinking, oh, m is the slope, b is the y-intercept, right? You just think x squared plus y squared equals r squared, and that's the equation of any circle whose center is at the origin. We'll do some stuff to move it around eventually, but that should totally make sense based on what we know about Pythagorean theorem. And you may be like, well, there's variables or whatever, but look, there's variables in my y equals mx plus b, the y and the x, right? So here we should have in our equation for a circle a y and an x. It just comes in the form of Pythagorean theorem. So last problem that I'm going to do in this video, I'm going to say, all right, I got x squared plus y squared is 64. I want you to graph it. So, well, I've got a 64 here, and I need to know, all right, what squared gives me 64? Well, if I square root that, I get 8. So that tells me that the radius is equal to 8 for this thing. Since it doesn't have any funky parts, it still is in that form as the red one above, I can just draw a little circle like this, and then label 8, 0, 0, comma 8, great handwriting, huh? Negative 8, comma 0, and then 0, comma negative 8. Boom, I'm done.